Alan. Hey, everyone. So, I bet you didn't wake up this morning thinking you were going to live hack a running Node.js application, but this is what we're going to do today. Did you know that many, many developers, 87% of them, go to sleep sad? Sometimes they even cry because of bad Node.js images. It is maybe true. So here's the Dockerfile, and we're going to walk through it and run some of this stuff. So here's this Dockerfile, pretty simple. If you try to run it, it just works, right? Simple as it gets. So running applications, we build the image, we run the container, and it's running, it's working. Except virtually everything in this Dockerfile directives is pretty wrong. Unless, of course, you're doing this for learning and testing, that's fine. But anything beyond that production-based, this is pretty bad. First of all, when we're doing from Node, do we know which packages are we pulling, which libraries are we pulling, which version of Node? Maybe not, so no reproducible builds. We'll see why later. Large software footprint. We're actually needing a lot of software to actually build this. There's an entire operating system that we're building into this. How about the sensitive data that we might be pulling in? So this Docker container is going to run in, and we're going to copy a lot of the data that we have on disk to this application. What if we're copying .env configuration files, credentials on disk? npm install. Bad way of putting dependencies onto a container this way, right? Even the directive that actually spawns the container process is bad, and we're going to see why. So my name is Liran Tal. I'm a developer advocate at Snyk, where we build developer-first security tools to help you, developers all over, myself as well, build applications securely using open source. I dabble around a lot of web security stuff through OWASP, Node.js, a bunch of stuff here, a bunch of people here if you want to join and have fun with it. Recently, a GitHub star. But today, I want to make you go to sleep happy, with a smile on your face, not sad. So let's see how, and let's hack a live container. First off, we're going to have this principle, and we're going to have a few of those best practices and principle of how to build applications. But one of them is how you actually build explicitly very deterministic-based container images when you want to run your Node.js containers. So as we said in the beginning, from Node, this is kind of like so-so. This is not the best way of doing it. Let's see why. First of all, how many of you can say exactly which version of Node.js runtime do they have in production? Exactly, Semver, Minor, and Patch. Right? A few, that's good. It's not a lot. If we're doing from Node, we're always going to get latest. Latest version that's going to get pushed to the registry of the Node Docker images. So which are we getting? We're not sure. Also, it's not reproducible builds. If there's a new version that was pushed, a new image tag for the Docker container, between our builds or between deployments, that's going to be non-deterministic. What I'm saying here is we're using a lot of log files on NPM projects, right? Package log, kernel log, all of those things, to basically pin our dependencies down. So why are we not doing the exact same thing when we're building Docker-based Node containers? We should. The other issue, as we said before, there's a large software footprint. We're building a lot of operating system-related libraries, like JPG, like GNU, like GCC, all of those kind of libraries that we may or may not need on the running container itself. Here's an example, a real test that I did a couple of years ago, showing all of the top 10 most popular Docker container images on Docker Hub, right? And then I did a scan of all of them which have vulnerabilities in them. You can see Node is, of course, winning the race here, not in a good way. And this is the default, right? If you do from Node latest at this point in time, when I ran this scan, I would actually run my container with the default of 632 vulnerabilities, which is not so fine. So let's have reproducible builds. We can use SHAs. We can use basically the message hash of the image that I want to use. So I can just put it like that, but of course you're going to tell me, hey, Liran, you know, this is not very maintainable. If I want to code review this and know which exactly container version I'm actually running in production, by just viewing the Docker file, I wouldn't know. So what do? Use aliases. This helps. You still need to hash it, because this means that you will always build the exact same copy, the exact same image layer of the container image. But if you want to know what it is and you do not know just by the hash itself, use this aliasing, LTS-alpine. How about optimizing Node.js applications to run for production? This is beyond all the tooling, and this is the really basic stuff that we should do. Some people, in some of these tutorials that I was reading that are very, very simplistic, they do like this. Run node-env equals production. You know what this does, right? It basically does like an npm install minus production. You do not get the dev dependencies. Great, but some libraries, like example Express, if you're using the Express web application framework, it actually has specific conditions in code, or at least had at one point in time, where it will only create caching and less verbose error messages. So basically, production-related configuration only when you pass it node-env production. When you do it in the command itself, like this when you install, it's not part of the running process. So how do you do it? Like this. Node-env production, then any libraries that actually take a look at this, configuration, parameter, environment variable, in the Dockerfile, that's how it gets run, and they are optimized. So we're good. The running containers in production basically means we should actually take a look at not forgetting one of those old Unix philosophies, the principle of least privilege, right? Not running containers as root. It sounds so simple, yet the default is very, very far from it. The default of running containers, if you containerize your Node.js applications, use a simple Dockerfile like this, npm start. That basically runs the process as who owns it? The default is root. That's how it works. Let's take an example of like why is this bad, and we'll hack a live container soon, but we'll build a story of why this is bad. Let's say you have this child process exec, which is not a secure way of executing commands. But still, like, what if CMD is user controlled? What if my user input as a malicious user could actually flow into this? Right now, if I do something bad with the application, there's a vulnerability with my code, my dependencies, with something, then a container is now running my process as root. And I could actually now leverage myself maybe outside of the container to the host and other things that I shouldn't be able to do. Let's take a different example. Let's say you're not using child process exec. Let's say you're actually using some dependencies, for example, PDF image, because I have some worker thread, I have some worker Node.js applications in my message queue that needs to process images. I'm going to use this PDF image library. I'm going to feed it this PDF file path, which maybe comes from the user because maybe it has the name of it or something else. So it's user-controlled. And then that actually flows right into the logic of the application itself. Now, this isn't just any library. PDF image is a real library that has real vulnerabilities in it, specifically arbitrary code injection, specifically remote command injection. All of those. If you're using this library, please move away from it. But hopefully you're not. So it sounds easy. It sounds that we should just have another Dockerfile instruction that says, change the user ownership when you run the application, depending where you want to put it. And like this is already now going into optimizing image layers, which I do not want to speak about in this specific session. But there's something missing here. Of course, we're dropping the privileges. If you're using Alpine base images, like you could see at the top, user node is already built in. So you do not need to add specific instructions to add it or create it. But what about the files that we copied before that, right? They are owned by root. So the complete example is actually that you should copy the exact ownership of the file when you move them to the container itself. And then it's a lot better. Terminating Node.js apps. It's a very gloomy way to think about applications, right? What happens when they die? But they do. Sometimes they need to die. Sometimes they need to go off. Let's see what works. A lot of those blogs and tutorials that you will read out there is telling you, run cmd npm start. This is bad. So you move to a different tutorial. Yarn start. You see the difference? This is what's called the shell form and the exec form. Now it's square brackets. It still works. It behaves a bit differently. But it's also bad. So maybe you're thinking, hey, I'll try a different way of running my application, which is directly invoking the node process. Also bad, and maybe you're thinking also about perhaps potentially also wrapping it with a shell script. Also potentially bad because you're probably not doing the right stuff in that shell script. Why are they all bad in all of those tutorials and whatever you're doing in production maybe today? Let's think about it for a second. Those applications that you're running, those containers running in production, they need to be orchestrated. Beyond someone spinning up new containers all the time, they also need to scale down. They need to get terminated at some point in time, right? The way that they do it, Docker Swarm, Kubernetes, whatever works for you in production, has this mechanism that when the application needs to turn down, it sends a sig term, a signal kill, some kind of process signals that the process can take it inside a container, understand it needs to go down. But all of those ways that we've seen before that just do not work, all of those instructions in the Dockerfile just do not work. Why? Because when you do npm start, you basically do two things here. You run npm as the first process, which then spawns a child process for your application, for Node. And then it does not actually forward all of those sig term, sig hang up, and all of those signal processes that could flow in it. Okay, so this is why it will not work. Now, I can show it to you. You can take this example at home and try it out. Simply listen to the process handler of signal hop, which is a signal hang up. Run a Docker kill with that specific signal that you're sending to it. Of course, in the other window, you have the Docker run of your running container, and you will see it does not do anything. It simply does not respond. It cannot gracefully shut down. How do we fix it? We said there's another way to do it, right? Like maybe we can do it through a different way. Maybe we can do node start. It's a different form of running execution of processes inside containers. But look at this now. Who actually owns this process? So this actually, there's the exec form and the shell form. When you're using the shell form notation, it actually says it's going to launch this process ID 1 as the shell, and then drop privileges and bring it back to the node. You can see it here in my screenshot. So it's maybe OK, maybe not. Still, it depends if you're forwarding those signals or not. Most of the time, it just doesn't work. So you try a different one. Try exec form, right? The other example that we said is also bad. So if you try this, what happens? Node is supposed to start as process ID 1, as the process ID that gets the container signals. But hey, there's a Node.js Docker working group, a bunch of people who said Node was not designed to be the init process. It is not designed to be working this way, so you should not really work this way. How do we fix it? If you're using LTS Alpine as your base image, and this is just as an example of a base image, there's an APK you can install called dump init, which you can install it for other base OSs for containers. It doesn't really matter. Start it off like this, and what dump init does is it actually starts off. It's a really, really lightweight, small init system that gets all of those signals. It knows how to handle them, how to completely forward them to your application in a safe and great way. So there we go. We now basically want to gracefully terminate our applications. There's a small tip I'll add also to this, which is if you want to clean up your resources, probably want to assign a process handler as well, a function handler, to those signals that says, hey, when I'm shutting down, when I'm getting that signal hang up, I actually should be, for example, terminating all of my web application requests, like Fastify stop or stuff like that, so you do not actually continue to receive new requests. You want to shut down the applications cleanly, databases, whatever needs to happen. So why don't you not fix your vulnerable Node.js Docker images, right? Let's get to the live hacking part. Let's talk about it for a second. You do Docker scan, or whatever way you're doing to basically find vulnerabilities in your containerized applications. If you're doing this, you're probably getting a lot of results, right? I'm basically doing Docker scan, whatever image I want to feed it. And it tells me I have this image magic vulnerability. It's from that and that version. Interesting. It's also coming from this specific image layer, which is actually pretty interesting and useful because now I know where it's coming from. It's not from an instruction that I added to the Dockerfile, which is like run, apt, get, install image magic. It's not coming from that. Specifically, it's coming from the image itself. And there's a vulnerability there. High severity vulnerability, XML injection. Who knows? So at the end of the day, you actually come up with these 624 vulnerabilities. What do I do about it now? Most of the time, I'm pretty sure you ignore it, right? Like, there's so many vulnerabilities in my container. What can happen? So let's hack a Node application and see what can actually happen. Hope the demo gods are going to stay along here for the rest of the show. I'm going to make this a bit bigger. Great. So we have this application, very, very simple one. I'll show you package.json. Very simple. It basically has Express and Multra because I want to upload files. Remember my example before? Imagine this is simply a node container that works off of a message queue, right? It's some worker thread in the background. It doesn't even receive any actual live HTTP traffic. Just takes some data, works on it. What does it do? It actually resizes images. So you can see I have some uploads folder. Everything is super simple here just for brevity. I have this post to upload files. I'm doing child process exec file. This is a secure way of running my child process commands. Running convert. Convert, apparently, I did some research. Apparently, this is a way for me to provide files on the disk. And what it will do, it allows me to say, hey, resize it to a specific image and do a bunch of image manipulation things. I do it this way because I know that Node is single-threaded, so I probably do not want to block the CPU by doing CPU-bound and specific computation, like manipulating images. So I use this. By the way, I might have used PDF image or some other libraries that would abstract all of that away for me, but essentially, this is what they mostly use instead of some lower-level actual multi-threaded operations. So this is a pretty easy example, and I have it available on /public. So let's see how this works. So I'll make this a bit bigger as well. Docker run. Let me show you the Dockerfile here. From Node 6. Who's using Node 6? OK. I think you're still using it? OK, we'll talk later. We'll talk later. So Node 6, we still have it. This is, I'm not even installing anything on this base image. This is just Node 6. npm start, all the simple stuff that should work. Looks like it's up. OK, we said it's /public, right? OK, great. So it looks like I can just upload images here. Now I want to shell inside a container called RCE because we're going to have a remote code injection there. And now I'm inside a container itself. This is running locally, but it's still running. This is a live container running. It could run anywhere, right? You can see my files here. I have the Dockerfile. I have the server.js, the simple stuff, the uploads directory, the public directory, and some other stuff, OK? All good. Let's upload a file. Liran Yoda hat picture. That looks nice. Let's see. OK. It's not my Yoda picture. Let's see what actually happened. If I take a look at what the file system status is now, those of you who are able to see what's going on here is basically a new file called RCE0 got created on the file system. That's just by me uploading a file, which is a basic thing we do in the web today, right? Twitter, Facebook, whatever you want to do, you basically upload pictures, and they are user-controlled. The file name, the contents, everything is. Why is that? That's because there's a vulnerability in ImageMagick that allows me to exploit the fact that there's some vulnerability there, specifically improper input sanitization. Let me show you the contents of that image. Right? This is how it looks like. This is the file that I uploaded. It's a valid image that ImageMagick actually accepts those images. It's called the delegate feature that ImageMagick supports. It allows you to say how to build the image, what's the viewport like, the resolution, everything. I can fill the data of the bitmap from somewhere else, which is this. But then you see it has a command injection that allows me. The fact that it doesn't sanitize this allows me to upload a picture that then, when processed and spawned as an ImageMagick convert utility, is actually creating the file. Now, we can run further with this example, and let me show you what I'll do next. So I want to take something even more complicated, and that is and this simple exploit payload that I have here is a bit more complicated, but it's a lot more fun than just creating files on the system. By the way, this is not anything beyond like my coding practices in Node.js. This only happens because I just spawned a shell process, right, that has ImageMagick as a vulnerability inside a container image. Now, this one is a bit more interesting because now we're going to have a remote reverse shell. So you might think, well, what can happen? We have all of those runtime protection. We have all of those protections on the container itself and around it. But this is not me SSHing into the container. I can actually get the container to SSH back to me on a port like 80 or 443, which is legitimate. So let's do something. This is a nice way to simulate it. I'm going to upload it, but for that, we're going to need to set up some of the environments. I'm going to have, actually, I need to cd into exploits here. Let's see if this works for us. So here I'm actually going to serve, HTTP serve, my netcat, because that's a network utility that I have on my Linux machine inside the container itself, because it doesn't exist in that node 6. But I need to have it there. And then I will need to just do it like this. Use netcat on my system to actually receive the incoming connection. It's now listening on this port. So if I got everything right, the only thing we really need at this point is to upload RCE2, our new payload. Now, it's taking some time. Why is it taking some time when things before worked just well? Well, RCE2, if you remember, I'll print it again here. If you remember, RCE2 actually needs to download stuff. So it takes the exact same sort of exploitation attack payload, where it actually needs to wget all of this data. RSH is my internal script, and then runs it. RSH for me is this one. It's now downloading that netcat that I have with my local HTTP server, which is serve in the other window. Downloading netcat, actually need to extract it, compile it on the container itself, and then make it connect back to me. Okay, so all of that is working. And if we have everything working just fine now, almost fine. But I basically now have a way to run commands inside the container itself. So this running container is now allowing me to execute commands of whatever I basically want inside that container. Now, let's say I want to fix this problem. So I move back into the future and move from 6 to 8.5. Let's stop this, and move back now to 8.5. So I need to stop the running container. And to do that, let's say we take 8.5.0, right? Back in time when we were using Node 6, moved on to the new long-term support. At that point in time, this was 8.5.0. Let's see if I can rebuild this container fast. Rebuild, there we go. Of course. So I'm rebuilding the same container because I know I need to get rid of the image magic vulnerability, right? I want something else. I want a new container, base image, base libraries, new versions of them where this is fixed. Let's run this one again. See if it remembers this. OK. I have a new running application. If I go back here, let's see if it works. So it still works. The same application, I just upgraded to a new image. What I want to do now is tell you, hey, there's a vulnerability in the Node.js runtime. Who knows that there are vulnerabilities in Node.js? Right? You know this. There are vulnerabilities. 8 so far this year. 8 security releases of Node.js. Different vulnerabilities, but 8 security releases. So now what I want to do is take one of them, and let's see if we can get this one to work. I'll do something as simple as that. It's quick, so let me show you how this works. So I basically did curl HTTP localhost 3.1.1.2, and this is the actual payload that for Node 8.5.0 has a vulnerability that allows path traversal. So again, now this is basically my code is fine, my dependencies are fine, my container image is fine. The problem is Node runtime. I did not update it. I did not know it has vulnerabilities in it. And now I can actually access files inside it. Actually take that whole thing and turn that into user source goof server.js. So if you have, that's what I showed you before, that's the code running. If you have credentials, environment variables, they're running as some configuration file, then it's all there. And I can actually access it. Okay, so definitely upgrade. And be aware that we have vulnerabilities in Node.js runtimes. And then security releases to fix them. So you should always be up to date on those things. This is specifically the exact vulnerability that we have actually exploited. Other recent versions are also vulnerable, so please update. So what now, right? What do you do with this? So we have 624 in this specific image. And we're wondering, what should we move to, right? What's another base image? I actually took a look into Docker Hub and saw there are about 4,000 different base image tags that you could move to. 14, 10, 1, right? All the minor version. Dash Slim, Dash Buster, Dash the different distributions and all of those permutations available. So what do you do when you need to cope with this? So the beautiful thing here is if you're using that Docker scan command or any the sneak application or something else that's useful for you, but it really needs to help you, right? And this is where those things shine. If you're using Docker scan to run those Docker image vulnerability scans, it actually tells you recommended upgrades, like moving to 14.16 in our case, which has 561 vulnerabilities, not the best, but better than starting off with 600. But I can actually choose Buster Slim, which has 58. Maybe this works fine for my applications because, hey, you know what? It doesn't have image magic and a bunch of other utilities if I do not need them as part of the base image itself. So if you want more of those things, there's a whole blog post written by me and Omer, and then me and Yoni Goldberg, who I think is having another talk now or after, about all of those best practices of containerizing your applications. Make sure you scan them, okay? Scan, monitor, whatever tool you want, whatever works. Just do it because it's super important, especially all the Node runtime-related vulnerabilities and however you're building it. And if you have any other questions, I'm here for it. Thank you so much.